Time to have some fun and prove the equation of an ellipse. So, the definition of an ellipse, or one definition, is the set of points whose distance from the two foci add up to the length of the major axis. So, we're going to set up the set of points here that are whose distance from c comma 0 and negative c comma 0 add up to 2a. So, the idea being c comma 0 and negative c comma 0 are the foci. 2a is the length of the major axis. So, let us, what's the distance between this and that? They're going to both add up to 2a. Well, in order to find those distances, we're going to have to use the distance formula. So these are going to be two square roots. The distance from c is going to be x minus c squared plus y minus 0 squared. X plus c squared plus y minus 0 squared. And what I'm going to do is I'm going to simplify this. Simplify the left side. And now, this is going to be weird, we're going to square both sides of the equation. And what I know about squaring is that when I square, say, x plus y squared, it's going to give me x squared plus y squared plus 2xy. So, because I'm taking a square root and another square root and squaring them, I'm going to get rid of the square root once, get rid of the other square root, and then I'm going to do 2 times the other two square roots. So, here's the first thing squared. Here's the second thing squared. And then 2 times the first square root times the second square root. So x minus c squared plus y squared times x plus c squared plus y squared equals 2a. Whoop! I squared both sides, so I need to square the other side. That is going to become 4a squared. Now, if we simplify all these x minus c squareds and x plus y plus c squareds, well, what that's going to turn into is this is x squared plus c squared minus 2xc plus y squared. The next piece is x squared plus c squared plus 2xc plus y squared. Underneath the radical, we get a similar thing going on. X squared plus c squared minus 2xc plus y squared times x squared plus c squared plus 2xc plus y squared equals 4a squared. There are some like terms that we can combine here. So we have x squareds, we have c squareds, we have y squareds, and these are going to cancel. So we get 2x squared plus 2y squared plus 2c squared, and now we're getting to be under the radical, plus 2 times the square root of, and I'm going to treat this as two separate things multiplied together. I'm going to treat this as x squared plus y squared plus c squared minus 2xc is that first bracket. The second bracket, I'm going to put this 2xc separately. So x squared plus y squared plus c squared plus 2xc equals 4a squared. And the reason that I'm grouping this is because these two are the same, these two are the same, and there's addition here, subtraction there. So this is a difference of squares underneath the radical. So everything here stays the same. 2x squared plus 2y squared plus 2c squared. This is a difference of squares, so when we do a difference of squares, again, this is not that. Difference of squares is we have the same thing twice, one with addition, one with subtraction, and we end up with x squared minus y squared. So what's happening here, this is going to be squared, x squared plus y squared plus c squared squared, and now we're going to have the negative 2xc is all going to be squared as well, and that equals 4a squared. Okay, everything in this problem right now is divisible by 2, so let's divide everything by 2. So we get x squared plus y squared plus c squared plus this big square root, x squared plus y squared plus c squared squared minus 2xc squared equals, that's going to be 2a squared because we're dividing the whole thing by 2. Now let's move everything to the right side of the equation except for the square root, so then we can square both sides again. So moving these all over, we're going to be left with, on this side of the equation, just the radical, x squared plus y squared plus c squared squared minus, this is 4x squared c squared equals 2a squared minus x squared minus y squared minus c squared. Square both sides. Oh, goodness. Now the left side is square root. We're going to square both sides, and we just are left with x squared plus y squared plus c squared squared minus 4x squared c squared equals, well, this is, again, 2a squared minus all of these things being added up, so I'm going to treat this as that, do the first thing squared, do the second thing squared, and plus 2 times x times y. So the 2a squared is going to be squared. We are going to have x squared plus y squared plus c squared, and then minus 2 times the 2a squared times the x squared plus y squared plus c squared. I see that both sides of the equation have these, an x squared plus y squared plus c squared squareds. So those get canceled out, and we're left with negative 4x squared c squared equals, let's multiply this out, 4a to the 4th minus 4a squared times x squared plus y squared plus c squared. If we divide out the 4, we definitely don't want the 4a squared. Or sorry, yeah, the 4 we don't want. So we can get negative x squared c squared equals a to the fourth minus a squared x squared minus a squared y squared minus a squared c squared. Now, let's get all the x's and the y's on the same side of the equation. Get all the non-x's and y's on the same side of the equation. So get, let's see, where are the x's and the y's? Here's x's, here's y's. Move everything else to the other side of the equation. Yeah, so we'll move a to the fourth over here. A squared c squared here. Move that to the other side. X squared plus c squared, x squared c squared times minus a squared x squared minus a squared y squared. And now things should be coming together pretty nicely. So if we divide everything by a squared, we're left with negative a squared plus c squared equals 1 over a squared times, actually, I'm going to pull out the x squared to factor out of these two, which we're left with c squared minus a squared minus y squared. We have a substitution that we learned before, that we were told that c squared in ellipses is a squared minus b squared. Well, if we subtract a squared from both sides, we get c squared minus a squared equals negative b squared. So putting that in here we have c squared minus a squared is negative b squared. Now we have x squared over a squared. Here's negative b squared minus y squared. And lastly, if we divide by negative b squared cancels out here, leaving us x squared over a squared. And dividing by negative b squared, negative divided by negative cancels out. We get plus y squared over b squared, which is the formula when the center is at 0, 0. Just transforming it will give you the formula when the center is not 0, 0, which is 1 equals x minus h squared over a squared plus y minus k squared over b squared. Thank you.